Hi, I'm Shantanu Gata and I'll be explaining you Lcr series circuit. So, in this circuit, L is inductor, C is capacitor and R is the resistance. So, VL is the voltage across L, VC is the voltage across C and VR is voltage across R. V is equals to Vm sin omega t is a source which is AC source, and it gives an output AC of the form Vm sin omega t. Now, we'll write phasor diagram for individual components. So for L, that is inductor, the phasor is as follows, which is where I is the reference and VL is leading I by an angle 90 degree. For C, for the reference I, the VC, that is voltage across C, is lagging by an angle 90 degree. And for R, the voltage VR is in phase with current I. So this is VR and this is in phase with I. So now combining these three phasors, we can write an equation which is as follows. V is equals to VR plus J times, where J is the operator. VR is equals to V is equals to VR plus J into VL minus VC. Now VL minus VC is because VL is in upward direction, that is positive direction, and VC has a negative sign because VC is in negative direction, where this is VC. Okay, so we know that VR is nothing but I into R, where R is the resistance. VC is I into XC, where XC is capacitive reactance, and VL is I into XL, where XL is inductive reactance. So we'll substitute this in this equation. So we get V is equals to IR plus J times IXL minus IXC. Okay, so we'll take I outside and divide it to the V. So we get V by I is equals to R plus J times XL minus XC. So we know that from the definition of impedance, V by I is impedance. So we can substitute V by I as impedance. So Z, which is denoted, where Z is indication of impedance, as R plus J times XL minus XC. Okay, so now we can form a phasor diagram using this equation. Okay. Yeah. So for this equation, there are two cases. One where XL is greater than XC, and the other where XC is greater than XL. So for case 1, XL greater than XC, we can draw a phasor diagram as follows. This is I, which is the reference. This is VR, which is in phase. This is XL. Okay, this is XL and this is XC. You can see that XL, magnitude of XL is greater than XC. So when we subtract it, because they are at 180 degree, we can subtract it and we get it as XL minus XC. So if you draw, if we have the vector sum, we get this is Z. Okay, so vector sum is Z, which has an angle phi with I. Okay, so we can see here we can see that I is lagging by Z by an angle phi. So we can conclude that as XL is greater than XC, this is an inductive circuit and power factor is lagging. Okay, now in case 2, XC is greater than XL. Here the phasor diagram is as follows. See, now you can subtract XL from XC and we get XC minus XL, and the vector sum of this thing is Z, which has a phase minus phi. Okay, so we see that XC is greater than XL, so the circuit becomes capacitive and then the power factor is leading. So this is a derivation for LCR circuit. Thank you.